Okay, hi everybody. I hope you're having a wonderful weekend. So we are back to our workshop, and this is the second Falcon workshop. We had a physical workshop yesterday, training lag. So today we still have our mentor here with us to let us know more about building of Filecoin, data application, and we are looking forward to an amazing class here. So thank you everybody. Over to you, Timmy. Nice to have you here.
Okay. Good day, everyone. Nice to be here again. So I'll just go ahead to share my slide and share my screen, and then we could pick up from where we stopped yesterday. Can you see my screen? Sorry, can you see my screen?
Yes, I can see it. Can you hear me, Timmy?
Yeah, I can hear you. I can hear you.
Okay.
All right. Okay, good day, everyone. And it's nice to be here once again. So, yesterday we looked at hacking the data layer for AI with Filecoin, and we explored using the Synapse SDK to store data on chain. So today we're just going to look at methods with which we could store smaller data and methods which we could also store large data on Filecoin. So a bit about me. So I am Temiloluwa Adilowo, short for Temi, and I am a software engineer and Filecoin Orbit ambassador. And I've also been a serial hackathon participant and winner in a couple of them as well. So, once again, how I got into the Filecoin ecosystem, I mentioned yesterday that I was a hackathon builder and started Web3 hackathons back in 2022. And I did not contribute to a Filecoin hackathon until sometime in 2023, where I built and explored Filecoin technologies. I won a prize and then got to the Filecoin mainnet cohort, which was the cohort that was in place when Filecoin was launching the FVM. So since then, I've been a consistent builder in the ecosystem and currently an Orbit ambassador. So next, I think we'll just go into what we could do in today's workshop, what we'll be doing in today's workshop. And I think first would have to understand decentralized storage concepts, would understand how Filecoin and IPFS works, and then would also learn storage providers that we can use when we want to store data on Filecoin. So first things, we should learn about IPFS and Filecoin. So this is just an image showing the storage evolution of Filecoin. But before this, we'll just try to explain how IPFS works and how Filecoin works. So IPFS is the base layer, or like the underlying layer that makes all of this functional. And IPFS works with nodes, a network of nodes, where a user can store his data with. And this data you store is picked up by nodes, decentralized nodes around the world, and then stored on each node for you as a user. And Filecoin is very similar, but different in such a way that every node or storage provider ends on each data stored. So they all get incentives on the data they are storing for users. So that's the major difference between IPFS itself and Filecoin. So Filecoin enables incentives on storage, and then IPFS is just the P2P network that makes all of this functional. So then we have the layer one, which is the Filecoin virtual machine. So this was launched in I think 2023, and it's the storage layer that enables a user to compute over the stored data. So on the FVM, we have what we call actors. I mean, other blockchains have smart contracts as well, and they are very much similar. So this enables us to write contracts which we can deploy on the virtual machine. So these contracts can be written in Solidity and deployed on the virtual machine with tools like Hard Hat, Remix out of the box. So these are tools you would normally use in other ecosystems. So they can also be used in Filecoin's ecosystem out of the box. And we also have IPC, which is a layer two built on Filecoin itself. And this enables scalability. So each a user can spin up their own IPC subnet on Filecoin, and then this enables each blockchain to be scalable separately from the layer one itself. So we are just going to look to the kinds of data we as users can store on Filecoin and the providers that enable this storage. So first off, we can store smaller data. So this smaller data can be images, can be PDFs, could be any sort of document. It could be videos, it could be audio, just user specific. And then we could also store large data. So large data in this case is data above 1 gigabyte in size. So we're firstly going to look at storing smaller data. And to enable this, we would be using Lighthouse and Storacha as our case in point. So these providers are, Lighthouse is available at Lighthouse Storage, and Storacha, which it was formerly Web3.storage, is also available. And they provide SDKs. So these SDKs make it easier for you as a developer to easily integrate them in your own platforms. So I think they have TypeScript SDKs for those of us that are JavaScript developers and work with React, Node, out of the box. There are SDKs for that. And I think the Storacha has a Golang client, which is in development, and also a Python client, which is also under development. So using these SDKs provided by these providers, we can upload our data. So that's also easily accessible in um, your, in this case, I'll use TypeScript or React. So in your React project, you can easily import methods from the SDK directly that help you to upload this data. So firstly, you need your API keys, and these are provided by the platforms. Here we have Storage and Lighthouse. So they both provide API keys, and these keys would be requirements for you to upload your data or for you to interact with the SDKs. So on interaction, you upload your data. These storage providers package your data, that's Lighthouse and Storacha, and then gives you a content identifier. So this is a long string that stands as a unique identifier for each data you upload. So in case you want to uh, address or download this data later on, or you need to run computation on this data or just do something with it, you can easily access them using the CID provided. And once the CID is provided, stores your data, gives you a deal ID, and you can always access the data when you need it using the CID provided. So this CID can be accessed using any IPFS provider. So you just have, like on IPFS, ipfs.io/ipfs, and then you have the content identifier following it, and then you should be able to see information about the data you uploaded and also download the data if needed. So next, we're going to look at storing large data. So storing large data on Filecoin. And here we are also using the Filecoin service. So this is a new service that was more recently launched by the Filecoin team. And they also provide an SDK, which is called Synapse. So Synapse SDK is available on GitHub as well and can be used by any developer who needs. So we're just going to go into Filecoin services shortly. So basically, this is a service that enables you as a user to utilize decentralized storage directly using your on-chain cloud services, and you can access this using the Synapse SDK, like I mentioned earlier, with the link being displayed below. Nextly, we're just going to look at the process of uploading your data using the Synapse SDK. So using the SDK provided, you'd import your methods. So it's also a TypeScript SDK and can be used in your Next.js applications, in your React.js applications, or even your Node applications, seeing that they are all JavaScript and TypeScript related. So before you can upload your data on Synapse, I'll be using Synapse rather, you have to deposit USDFC tokens. So this serve as a method of payment for deals you are providing on the Filecoin network. To upload your data, you need to pay few tokens in as fees, but using Synapse, you pay in USDFC tokens instead. And this is a one-time setup, and you then approve the Pandora service for continuous payments. So initially, you can maybe allocate 10 USDFC or 100 USDFC to the Synapse SDK using the Synapse SDK, and then you approve the service for continuous payment. So this ensures that you don't have to deposit and approve every single time. So it's just going to be a single setup for multiple use on the ecosystem. So once you have approved the Pandora service for continuous payment, then you can move on to storing your data. And next, we would then create a storage service. So there's also a method for this on the Synapse SDK. So basically, what you have to do is to call this storage, call the method with your data, and it gets to create a storage service for you automatically. After creating the storage service, you then use that storage service to upload your data. So you upload your data using the specific storage service you have created for that data. And after uploading your data, the storage provider packages your data, in this case, Synapse, and it then gives you a comp ID. So this ID is what you have to use to retrieve your data later on, using also the methods provided in the SDK, the Synapse SDK. So after storing your data, you would need to retrieve your data as well. So we're just going to look at methods to retrieve your data. And since we looked at storing smaller data, storing larger data, we are just going to use the two identifiers provided by these storage providers that we have mentioned earlier. So if you remember when we are talking about storing smaller data using Lighthouse or Storacha, we mentioned CIDs, which mean content identifiers. So these content identifiers are basically the unique strings that help us to access the specific file or data we have uploaded on Filecoin. So we can easily retrieve our data using the same content identifiers like we have mentioned. So most SDKs, Lighthouse and Storacha, all have methods that we could use to retrieve our data. Basically, we pass in the CID as a requirement for the method being called, and the SDK helps us to process the download for that data, and we can all then retrieve our data and perform computations or anything we need to perform using the same data. And in the same manner, we have the comp ID provided by Synapse SDK. So this ID can also be used to retrieve data on our own platforms using the Synapse SDK. So the Synapse SDK provides a method for us. So where we call the Synapse SDK dot provider, and then we pass in the comp ID. And there are two methods to this. So the first method is using the method that requires us to use a specific provider. So this is the specific provider that helped to upload the data when it was being uploaded. Or we could use the second method, which ensures that we download our data regardless of which provider is hosting that. So these are the two possible methods for retrieving our data using either Lighthouse or Storacha or the Synapse SDK. And under the Synapse SDK, we've also seen two methods with which we could retrieve our data. So that being said, we have seen how to upload smaller data on Filecoin. We've also seen how to upload larger data on Filecoin using the direct on-chain service provided by Filecoin services. So far, we've learned about IPFS and Filecoin. We've explored methods to store smaller data. We've explored methods to store larger data. And we've also seen methods to retrieve our stored data on Filecoin. So using this data we have stored on Filecoin, we can perform computations, we can store data sets, we can store images, we can store videos, and various other data formats for whatever purposes we need to do. And bear in mind that this data we are storing is persistent and censorship resistant. So we have full control of our data on Filecoin. So this is the GitHub repository we used yesterday for the technical workshop we had physically. If you need to build or need a starter kit to help with your own integrations for whatever projects you're planning to build. And this is a link to the Field Builders Telegram channel where you have access to mentors and other builders in the Field ecosystem. So on the Telegram channel, you can ask whatever questions you have, and there would always be someone to, respond or provide clarity in whatever case you need. So for builders who also want to get involved in the Filecoin Orbit ecosystem, so basically Filecoin Orbit is a community ambassadorship program where we have every member of the community being able to represent Filecoin, spread the word about Filecoin, contribute to products being built, and speak on behalf of Filecoin. And for that, we have different orbits. We have the builder orbit, we have the creator orbit as well. So a ambassador is not restricted to a specific orbit. You can be in multiple orbits and still perform perfectly in all of that. So we could scan this QR code and get to join either of them. So far, once again, we should recap what we've done so far. So we've been able to learn how data storage is performed or done on IPFS and Filecoin, and also methods to store smaller data on Filecoin, as well as methods to store larger data on Filecoin. Then we've also seen how to retrieve our stored data and basically other ways to contribute to the Filecoin ecosystem. Right, over to you, Toluen. Thank you.
Yeah, thank you so much, Timmy, for the wonderful section, and I hope everybody has learned. So, if there's any question, you guys can actually drop it in the group, and the mentor will take it up from there. So, this Falcon workshop is to actually prepare us for the hackathon taking place next week, 7th and 8th. So, if you guys are participating, which I know you are all participating, make sure that you get across, you communicate in the group. If you have any question, they're there in the group to actually provide answer to it. Then we have Ethereum Nigeria Conference, the biggest gathering for 2025 coming up next week as well, next week Saturday. So by this time next week Saturday, we would have been in the conference already. So I will drop the link for registration in the comment section and encourage everybody to make sure that you attend, you share, either you're a developer or not. The conference is for everybody. And if your team is participating in the hackathon, make sure that you also communicate early. You have any question, you send that across. I will be more than happy to provide answers to them. So I think this is where we'll be drawing the curtain for today. Thank you so much, Timmy, for your time. And we are happy to have you here. Thank you.
Thank you so much.
Yeah.